So in this video, we're going to solve linear equations in one variable. We've got applications. Basically, we're going to solve for the indicated variable for the given equations. Okay, so the first one is the ideal gas law. PV equals nRT. And I want to solve for t. So what I'm going to do is I'm going to circle the letter that I'm looking to solve for. And I think, what's the operation holding these two together? So the operation is holding it together is multiplication. So the opposite, the inverse of multiplication is division. So all I'm going to do, I'm going to divide both sides by nr. And when I divide both sides by nr, now I can cancel. And so t is equal to PV divided by nr. And that's my answer right there. Okay, so really the trick is circle the letter you're trying to get by itself and then use algebra skills to do so. The next formula is area of a trapezoid, and I want to solve for the letter H. So I want to solve for H. So how do we do this? Well, what's holding this together? It's multiplication again. So the inverse of multiplication is division. So what do I need to do? Well, I need to divide, okay? I need to divide by 1/2, and I also need to divide by b, capital B plus lower b, lowercase b, and then I do it on both sides, okay? Now, this is a nasty way to do it, but it definitely gets you the answer. So H is equal to A divided by 1/2 capital B plus little b. But we can simplify this a little bit, all right? So the denominator here is a little bit complicated. We can fix this. This is A divided by, now 1/2 times big B plus little b. So we can write this as a fraction, capital B. So this is capital B plus little b over 1, right? So that's multiply 1 times the big B, little b, and then divide by 2. That's what we get when we multiply that denominator there. Okay, so now we've got ourselves a situation. We've got a fraction, and then there's a fraction in our fraction. So it's a compound fraction. So we need to do a little trick that I like to call KCF, all right? So we keep, change, flip. So keep, change, flip. So I keep the numerator the same. So the numerator is A, which is like A over 1, right? I change, what do I change? I change division to multiplication. And then I flip, I do the reciprocal of the denominator. Reciprocal of the denominator is 2 over b plus little b. And now I multiply across, and I get 2a divided by b plus little b. And that's my answer. That's what's solved for H there. Okay? So that's the keep, change, flip method. All right? Anytime you're dividing fractions, all right, you use the keep, change, flip trick. Now, volume of a right circular cone. I want to solve for H. So the first thing I do, I circle the letter I want to get by itself. What's holding this all together? It's multiplication. So I'm going to divide everything through. Okay? 1/3 pi r squared on both sides. 1/3 pi r squared. So H is equal to V divided by 1/3 pi r squared. Okay, now once again we've got a fraction and a fraction. I need to take care of this. Okay, so V is like V over 1, and then in the denominator, what is it? It's pi r squared divided by 3. So I have a fraction divided by a fraction, so I'm going to KCF it. So keep this the same, change division to multiplication, flip the denominator, 3 over pi r squared. And so what do I get? I get 3v divided by pi r squared. Okay, so that's how you would work it. Now, if you're not, you're not super comfortable with the keep, change, flip, you need to get comfortable with that. But you've got a little bit of time before we get into rational solving rational equations. But if you're not comfortable with it, another way you can solve this type of problem, if you have v equals 1/3 pi r squared h, right? Well, how do I get rid of this 1/3? Because I want to get rid of 1/3. Well, to get rid of 1/3, you can multiply by 3 on both sides. Remember, if you multiply by that least common denominator, you can get rid of the fractions. And as long as you multiply by the same thing on both sides, then your equal is still good to go. So that gets you 3v equals, and then those cancel, right? Those cancel with each other, and you have pi r squared h. And now you're seeing that this is looking a lot like what we had over here, right? Divide both sides by pi r squared, and we get the same answer. So that's another way to get your solution if you want to use that way for now. The reason I introduced this keep, change, flip method so soon is because you're going to be using that trick the rest of the semester. And so I want you to kind of get used to it and see the importance of it. All right, guys.